Okay, so today we're going to learn how to solve two-step inequalities. And the nice part about two-step inequalities is they're very similar to equations that we did in the last chapter. The only difference is going to be that we're going to have to show our answer in just a slightly different way. So let's take this one. Again, when you're trying to solve these things, you want to get x by itself. So we would add 4 to each side, and we would get 2x is greater than or equal to 12. And then we're going to divide by 2 to get 2 by itself. And in this case, we're going to get x is greater than or equal to 6. Now this is my answer, but this has a lot of different answers for this. So we want to actually show what that answer would look like. And to show what that answer would look like, we would graph this thing. So I'd make my number line. I'd have a point at 6, 7, and 5. And I would put, for this one, since it's equal to, I'd do a solid dot at 6. And since x is bigger than 6, I get all the numbers that are bigger, so 7, 8, and 9. And this, right here, would be my final answer. Okay? So the first part you do is you solve it, and then you have to graph it to kind of show what that thing would look like. So let's look at the second one. Again, we would kind of go through the same stuff we always do. Again, I would get rid of my subtraction first because you kind of go through and do a reverse PEMDAS. I would get 8 here. To get rid of a fraction, we'd multiply that dividing to get rid of it. I'd have 2x is less than 24. I'd divide by 2, and I would get x is less than 12. And again, this is my answer, but to show people, I would need to graph this. So I'd make a number line. 12 would be in my middle. I'd have 13, and I'd have 11. I would, this time, because it's not equal to, I'd make an open dot. And since x is less than 12, 12 is bigger, so I'd want to go away, like 11 and 10 would work in here. So this would be my final answer. Let's look at another example. Okay, so I'm going to solve this example. I'm going to subtract 3. I'm going to get negative 2x is greater than 6. I'm going to divide by negative 2. I'm going to divide by negative 2. And I'm going to get x is less than negative 3. So I want you to watch really carefully what I did. You see, right after I divided by this negative, my sign, which was facing this way, I flipped around and I faced the other way. In inequalities, anytime you divide or multiply by a negative, so anytime you divide or you multiply by a negative, you have to flip the inequality sign. And in a second I'll explain why. But you need to know that anytime you divide or multiply by a negative, the sign flips. We would then treat this again like normal, so that is my answer. We would graph this thing. Negative 3, negative 2, negative 4. Because now the sign is facing 3, I'm going to do an open circle and go this way because I'd want things that are lower than that. Let's talk real quickly on why this sign should flip. Okay, so just take any two numbers that you know are true, like 4 is bigger than 2. We know that. And then what I like to do is I like to just divide and multiply by a negative number and see what happens. So when you divide this by negative 2, I would then get negative 1 and negative 2. And if the sign was facing this way, that would mean that negative 2 is bigger than negative 1, which we know is untrue. So the sign would have to flip. So you can see that when you divide by this negative number, it does force this sign to flip. You could do the same game with multiplying, because you'd have 2 is bigger than 4. We know that's true. Just times this by a number, so I'm going to times it by negative 3. And you would see that this becomes negative 6, and this becomes negative 12. And if we kept the sign the same way, we would know, oh, that's not right. Negative 12 isn't bigger than negative 6, so it would have to flip. Okay, so anytime you multiply or divide by these negative numbers, you do need to flip these inequality signs. Let's do one more example. I'm going to just change this actually up a little bit as we go along to make it a little bit trickier. If you see this problem, we see that we have everything being divided by this 4. I need to get rid of it, so I'm going to multiply by 4 on each side. That will cancel it out. I'll then have negative 2x minus 5 is less than 28. I would then add 5 to each side, which that would give me negative 2x is less than 33. I would then need to divide by negative 2. When I divide by a negative number, it's going to flip my inequality sign, and I would be left on this one. Well, let's just see what this is. Negative 16.5. And that would be my answer. Again, after we find our answer, we're going to want to graph this thing. So we have our point at negative 16.5. This would be negative 16. This would be negative 17. I would make a open dot because it's not equal to. And then I want to go to the right because I want numbers, the x values are bigger than the negative 16. So it's got to go towards the side that is bigger. Try these problems today on MathSpace. If you get stuck, just let me know.